ladies and gentlemen, we're going to continue our work today on solving and graphing inequalities, and we wanted to create a video with a few examples to get you started. So, working from the beginning, you've seen problems like this one before. This says x is less than or equal to 6. Remember, seeing that underline means that it could be less than 6 or it could be equal to 6. So I could pick numbers that are smaller than 6 or include 6 as well. The first thing I'm going to do is find my boundary point, positive 6 in this case, and I need to decide whether this boundary point is going to be shaded in or left open. In this case, because I have x is less than or equal to 6, I'm going to shade in the boundary point to show that 6 is part of my solution. X being less than 6, I would shade in the negative direction toward my smaller values, remembering to include my arrow in my shading. This just shows that I know this is only a little piece of the number line, and the number line will continue in the negative direction, showing more solutions of numbers that would be less than 6. All of these numbers that are included in my shading are smaller than or equal to 6 itself. So that's kind of the first step. Next, we're going to see inequalities that start to look like this. They look like the equations that we were solving earlier in the year. So this says x minus 4 is greater than negative 7. I can't graph this as it is because there's another term stuck with the x. It says x minus 4, not just x. So just like we used to, we're going to isolate our variable. We're going to try our best to get the x by itself. I see a minus 4, and I know that the inverse or opposite is to add 4. So just like we used to with our equations, I'm going to add 4 to both sides. I've canceled out. Negative 4 plus 4 is 0. So I'm left with x is greater than negative 7 plus 4, which is negative 3. Now I have an inequality that I can graph. I'm first going to put my boundary point at negative 3. I see that my symbol says x has to be greater than negative 3, so I'm going to leave this circle open because negative 3 is not included in my answer. Negative 3 is not greater than negative 3. That doesn't make sense. I'm going to shade in the positive direction all the numbers that are larger than negative 3, including my arrow again. And that shows all of the numbers. Every number on the number line in that direction will be larger than negative 3. The last step, just like we did in equation solving, is to check our solution. So what I get to do is pick any point in my shaded region. Anywhere up here where we see shading, I can pick a point. So let's pick something, I don't know, let's say something like 8. That's my lucky number. That's my favorite one. I'm going to take this number and plug it back into my original inequality. Not just say 8 is greater than negative 3, yay, I'm done. I need to check in my original to make sure that in my rearranging I didn't make any mistakes. So I'm going to say 8 minus 4 should be greater than negative 7. 8 minus 4 is positive 4, which is larger than negative 7. A positive 4 is a bigger number than negative 7. So this check has worked. This step usually confuses people a little bit because you guys are so used to wanting to see the same number on both sides. So usually you would want to see something like 4 equals 4 or negative 7 equals negative 7. You'd want to see the same number on both sides. But remember, this isn't an equal sign. This is an inequality. So all we need to do is make sure that this statement is a true statement. Is 4 larger than negative 7? And in this case, the answer is yes. If your inequality check doesn't work out, like it says something silly like 2 is greater than 10 or something like that, that's how we know that we've made a mistake somewhere in our solving or our shading. All right, another example. This one looks a little different. It says 6 is greater than or equal to 3x. Again, I have something stuck to that x, so I can't graph it like it is. I know that 3x means 3 times x, so I'm going to do the opposite. Divide both sides by 3. I get the x by itself. 6 divided by 3 leaves me with 2. In previous videos, they've talked about how this expression is not as easy to read as when it starts with the variable. Saying that 2 is greater than something is different than talking about the something that we want to find. So the way that I envision this is I picture taking that whole rectangle, picking it up off the page, and flipping it over. So I need to say that x is actually less than or equal to positive 2. Notice that the opening of my inequality is pointing at the 2, just like it was here. I had to pick up the whole thing and reverse everything, not just the symbol, just the variable. I had to do the whole entire thing, but backwards. So now I'm ready to graph. My boundary point in this case is 2. It says that my x values this time are less than or equal to 2, so I can shade in and make a closed circle since 2 is included in our answer, and shade in the smaller direction. So down toward the negative numbers that are less than or smaller than a positive 2. Lastly, I'm going to do my check. So I need to pick a number somewhere in my shading. Let's say, I don't know, negative 3. It doesn't really matter. It's totally up to you. And I'm going to plug it back in to my original inequality. So 6 is greater than or equal to 3 times a negative 3. 6 is greater than or equal to a negative 9. So I have to say to myself, is 6 bigger than negative 9? Positive 6? Yes, it is. So I've shaded in the right direction, and everything's all set. Now, there is one exception to this rule, one special case that we need to worry about, and this is when we divide by a negative number. If you think about negative numbers, they change the sign of the number that you're starting with. So if I have, let's say, something like negative 10 divided by negative 5, a negative divided by a negative would give me a positive answer. It would give me positive 2. On the other hand, if I started with positive 10 and was dividing by negative 5, that would give me an answer of negative 2. So dividing by a negative always changes the sign from what we started with and what we ended with. Because of that, we need to be really careful with inequalities that deal with dividing by a negative number. In this case, in order to get x by itself, I see that I need to divide by negative 2. When I write divided by negative 2, divided by negative 2, I know that this is going to change the sign of my number. This is going to change the sign of my answer. This should pull off a red flag in your head. And whenever we divide by a negative number, we also need to turn our inequality symbol around. When we take our inequality, we need to reverse it since our symbols and our positive versus negative association is changing. So in this case, I know that this cancels out and leaves x by itself. 6 divided by a negative 2 is going to give me a negative 3. And I need to turn that symbol around. So just the symbol is turning around, not everything like we previously did. This expression now says all of my x values have to be larger than negative 3. So I'm going to put my boundary point on negative 3. I'm going to leave it open because this is a greater than symbol. And I'm going to shade in the positive direction. So all of these numbers that are larger than a negative 3. Now, just for a moment, we're going to pretend that I forgot to turn the symbol around because that is the most common mistake. That is the thing that we see students miss a lot. So we'll pretend that I forgot that. We'll pretend that I have something that says x is less than negative 3 and pretend that I shaded in this direction by mistake. I want to show you a check that does not work so that you can see when this comes up, it is not correct. So let's pick a number, I don't know, let's say negative 6. We'll pretend, all right, I shaded this way. I'm going to use negative 6 in my check. When I plug negative 6 in, I get an expression that says negative 2 times negative 6 should be smaller than positive 6. I know that negative 2 times negative 6, a negative times a negative, is going to give me a positive answer, in this case, positive 12. Is positive 12 less than 6? Does that make sense? No. This is an untrue inequality. 12 is not less than 6. So that should tell me that something is wrong, either with my solving or my shading. So now let's get rid of this wrong check, and let's do it the right way. If I pick a number in my solution set, let's say positive 2, and plug it in, I get an expression that says negative 2 times positive 2 has to be less than 6. A negative 2 times a positive 2 is going to give me an answer of negative 4, which is indeed smaller than a positive 6. So trust us that if your check is not working and you end up with something crazy like 10 is less than negative 5, you need to go back and figure out what happened because that means that either your solving has a problem or you shaded in the wrong direction. Thank you guys so much for tuning in. Get to that IXL.